Hello everyone, welcome back to another study buddy tutorial. In this video we'll be talking about polar covalent bonds. This is our next video in the series of the structure of matter. The last couple videos we talked about essentially what is bonding and what is non-polar covalent bonds. So let's go ahead and start with some recap of our last couple videos to get a quick refresher. Okay, atoms want to bond to attain a noble gas configuration, that octet. This means that they want 8 electrons in outermost shell. This means that they are stable, and that this is also how our noble gases are. So they want to essentially have a full octet in their outermost shell valence electrons. To be that's why they bond. That's why they either give away electrons or get more electrons. So then we move on to ionic bonding. Ionic bonding is a transfer of electrons to get an octet of electrons. So they transfer, meaning they give away. So if they have an extra, they lose that electron rather than sharing it or something. Or if they have one less and they get it from somewhere else. And that's how they bond. That's how their bond is made, the ionic bond. And then ionic bonds are also between a metal and a non-metal. Then we move on to covalent bonding. Covalent bonding is when they share electrons to get a full octet. This was in our last video, we talked about this. And this is only between two non-metals. So there's no metals involved in this. It's share. Either if there's two needed, then they'll share those two. If there's one, then they'll share the one. Now, covalent bond, there's two types we talked about. There's nonpolar covalent, and there's polar covalent. In the last video, we talked about nonpolar covalent is when valence electrons are shared equally. That means both atoms or elements are giving away one, and there's no polarity in between them. While polar covalent bonds, valence electrons are shared unequally, which we'll talk about in this video. So if you have any questions about non-polar covalent bond, check out part 2 of this video series. Alright, so now with the recaps done, we'll go ahead and move on. So, polar covalent bonds, again, valence electrons are shared unequally. This means that one atom has a stronger pull of electrons. That possibly means that since that electron is kind of sharing more electrons, it will have a stronger pull. It creates a slightly negative end, signified by this, and a slightly positive end, signified by that. Some examples would be HF, HCl, CH4, and many more. And this is a quick visual. You can see HF, the fluorine, and the fluorine atom here, electron here, and then the hydrogen electron here are bonding. And this shows it's unequally shared electrons because you would see that fluorine has more electrons and it's unequal because it's only one versus how many here. This creates those negative and positive ends. You see fluorine being the negative end because it has more electrons. So more electrons is equal to negative end. So our negative end. And then less electrons obviously would be positive, as you can see here. Alright, okay, let's move on. Yeah, this is just a more enlarged picture. You can see more clearly how this is where that bond is happening, this shaded region here. And this is where the unequally shared electrons exist. And these are the unshared electrons. Versus, same thing here, would be the unshared electrons here. But you're not seeing anything here because hydrogen only needs those two because it's one of our exceptions. Then we have our positive end here. And we also have our negative end here. And again, since fluorine has more electrons, more unshared electrons, it has a stronger attraction for shared electrons. So if you were to see an image of this, fluorine would be stronger. Okay, so now that we have learned basically what they are, what is the difference between polar bonds versus nonpolar bonds? Again, we talked about in the last video that polar bonds are between typically the same elements. So you can think of your H2s, F2s, Cl2s, O2s, N2s, so whatever typically between. This is not a hard rule, but it's most common between two of the same elements. While polar bonds are typically between different elements. You can see your waters in this polar bond to be water. You can say CH4 as well, and NH3, and so many more. So essentially the difference is between the number of elements and the same elements. So nonpolar means same elements. This depends on what level of chemistry you're on. You might want to check with your teacher or professor on that. And polar bonds are between different elements. And here's just examples of nonpolar bonds. Again, I told you chlorine, so Cl2 is bonding here. You can see a Lewis dot structure. These are called Lewis dot structures. You'll see all of them here. And we'll talk about this in the next video, which I'll get to in a minute. And yeah, so you see Cl2, O2 is here, N2. These are nonpolar bonds. And then our polar bonds are water, NH3. And polar bonds, this is when you have the positive and negative ends due to unequal sharing of electrons. Versus a nonpolar, you don't see that because they're all shared equally. Yeah, so there's some Lewis dot structures, NH3, CH4. Okay. So that's it for today's video. That was just a quick refresher and introduction to polar bonds, polar covalent bonds. In the next video, we'll be covering, again, as I said earlier, Lewis dot structures, which are the ones that I showed you in the previous slide. Lewis dot structures here, and these are how they look like. But yeah, that's the next video. I should play it in the sequence. But if you could please subscribe, like, comment, share, it would really help me out. Thanks for watching. If you guys have any suggestions or have any topic you'd like me to review, please let me know it in the comments below. I also have an email that I've attached in the description box, so feel free to do that. I'll make content or whatever subject you need in. Alright, thanks for watching. Again, make sure to please like, share, subscribe. And thanks for watching. I'll see you guys in the next video.